Hi everyone, this is Professor Nancy Mahan. In this video, I am going to go over a problem that a classmate had on graphing parabolas. So in this problem, we have a classmate that asked, how can you graph a parabola with y is equal to x plus 2 squared minus 5? So we're graphing a parabola of this form, and it's been driving him crazy.
So that's a great question. I rewrote it down on paper. So we want to graph a parabola that is in this form. So the first thing you need to know how to do is graphing parabolas is, what is the formula for graphing a parabola? And the formula is this. If an equation is in the form of this, there's several things you can know looking at a parabola that's of this form. The first thing you would know is the vertex. So the vertex of a parabola, so remember, a parabola could look like a happy face or it could look like a sad face, right? And what a parabola has is a point here that we call the vertex. And the vertex is the point where the parabola changes directions. Here it's going down, then it's going up. Here it's going up, and then it's going down. So the vertex is that point in which it changes direction. So a vertex, if you have a parabola in this form, the vertex is going to be h comma k, which is called Hong Kong, hk, just to remember it. So it's x minus h. So the h is going to be the opposite of what you see here. So h is not going to be 2, but negative 2. Since it's x minus h, you could write this as x minus a negative 2. So if you see a 2 here, the h is going to be negative 2. And then the k is plus k, whatever is this here. So this is like x minus a negative 2 squared plus a negative 5. So here the k is going to be negative 5. So one way of just thinking about it is I just think of opposite, then the same. So opposite of 2 is negative 2, and the same of negative 5 is just negative 5. So in step 1, identify the vertex. The vertex in this problem is going to be negative 2 comma 5. So again, the opposite of 2, which is negative 2, and the same here, which is negative 5. Negative 5, sorry. So negative 2 comma negative 5. So that's the vertex. The other thing that you can know about a parabola when you look at this formula is the letter A. If A is positive, if it's a positive number, then it's going to look like a happy face because positive things are happy, right? And then if A is negative, then it's going to be a sad face. Well, looking at this problem, what is our A in this problem? It's going to be whatever number that's in front of this quantity here. Well, the number up here is just a 1. It's just a positive 1. It's invisible. It's a positive 1, so it's positive. So I know that the shape of this parabola is going to look like a happy face, right? So here we know what the vertex is, and we know the shape of it. It's going to look like a happy face. So negative 2, negative 5. I'm going to identify the vertex. So negative 2 and then negative 5. So there's my vertex, right? And something else that you need to know about parabolas is that where the vertex occurs, if you drew an invisible line through the vertex, this is what we call the axis of symmetry. And the axis of symmetry is basically this invisible line that everything on the left-hand side, if you fold this paper in half, or if you fold the paper at the axis of symmetry, it's symmetrical on the left side and on the right side. It's a mirror image of each other. So you can expect at the vertex on the left side and on the right side, it'll be a mirror image. So that's important to note because the next step now is we're going to plot 2 points to the left of the vertex and 2 points to the right of the vertex. And note that it's going to be symmetrical when you do this. So I already know that my parabola here, there's a vertex. I know it's going to look like a happy face, right? But the question is it going to be a wide happy face or is it going to be a narrow, a skinny happy face? So you won't know how wide or narrow the happy face is or the parabola is until you plot points. So we're going to plot points to the left of the vertex and to the right of the vertex. So when I do that, I'm going to create a table of data. And I'm going to pick points to the left of the vertex and then points to the right of the vertex. So here, this is -2. So if I pick an x to the left of -2, I'm going to pick -3. And one more point to the left of -3, I'm going to pick -4. Similarly, to the right of the vertex, here's -2. To the right of -2 is -1. And to the right of -1 is 0. So I just picked 2 points to the left of the vertex and 2 points to the right of the vertex. So when I look at this, -3, I want to find out what the y value is. All I do is I plug the -3 into the original equation to find out what my y value is. So let's plug -3 in here. If I plug -3 in here, I get, if I plug -3 in, I get y is equal to -3 plus 2 squared minus 5. I end up getting -1 squared minus 5, which is +1 minus 5, which is equal to -4. So that's what happens when I plug -3 into the function. I get -4. Okay, so -4, so here's my point, -3, -4. So if I plot that, I have -3, -4. Okay, so now I'm going to plug one more point to the left of this, which is -4. So when I plug -4 into this here, so if I plug -4 in, I get y is equal to -4 plus 2 squared minus 5. So if I plug -4 in for x, I end up getting -2 squared minus 5, which is equal to 4 minus 5, which is equal to -1. So my y value is -1 when x is -4. So when I plot that in, when x is -4, y is going to be -1. -4, -1. And notice, here's the vertex. Hey, it's looking like a happy face. That's exactly what I want it to look like, a happy face. If I'm drawing points down here, then I know I did something wrong. So it's looking like a happy face. Now let's go to the right of the vertex. When I plug -1 in here, so just long story short, just to get to the point, if I plug -1 in here, I am going to get -4. When I plug 0 in here, I'm going to get 0 plus 2, which is 2. 2 squared is 4. 4 minus 5 is -1. And what do you know? These are exactly the same values, and that's because a parabola is symmetrical. So here, -1, I get -4. And at 0, I get -1. So as you can see, so pretend I actually drew through this. As you can see, this is a parabola with a vertex here, and the left side is symmetrical to the right side. Hope that makes sense. Let me know if you have any more questions.